So welcome again. I am Bill's brother, Brad, as he said, and I was lucky enough to be a part of this project for the new Dynamit.com. This launched early April of 2014, so we're coming up on a year now. We've had a lot of really interesting findings over that year. It's changed a little bit. Some of what we've built has changed, but I'm going to talk more about what we originally delivered in April of last year, and maybe talk a little bit about some of the changes. So a little bit about me. I'm one of the directors of technology at Dynamit. I head up the PHP and the front end development teams there. So I got to, again, be a big part of this project, mostly because of that. Like most of us here, been in this industry a while. As Bill said, our experience started in the mid-90s with a lot of this stuff. So coming up on 20 years. Very passionate about web performance. That's one of the things that I really am vocal about and evangelize at Dynamit is keeping things speedy, both from a front end and from a back end perspective. I don't like overhead. I'm kind of a clean code enthusiast. I don't like excess in pretty much any way. And you can hit me up on Twitter. I don't use Twitter as much as I probably should, but if you would like to, that's my Twitter name. Pretty easy to remember if you remember anything about me at all. So. Project overview. So, again, this is a project that I was lucky enough to be a part of. They approached us, Donatos did, really late in 2013. They had a series of events that happened that year that were not great for their company. They had a couple website crashes due to some performance bugs. They also, their web business wasn't doing what they wanted it to do. It wasn't as big of a part of their sales process as they wanted it to be, as they knew that it could be. People still picked up the phone and called the stores to order pizza a lot, which is something that they wanted to discourage because it's a lot easier to track customers, it's a lot easier to gather information, it's a lot easier to increase that ticket size, which is really what they wanted to do if you're ordering online. So they approached us. We got to do a full planning, design, and development cycle for the entire .com, which was really exciting. Anything was on the table. They're a really great company. They're very progressive in terms of how they approached us. They didn't come to us with any suggestions of this is the way we're going to do things. They really wanted us to provide recommendations and figure out from a tech perspective what really needed to happen. So that was a really great project to be a part of, with a couple exceptions. They did have an existing POS service that we had to use. This was not a thing that was up for debate. It would have been a multi-million-dollar project to redo that POS, and while that project is ongoing today, it's not something that was in scope for that project. So it's a Tomcat service, Java Tomcat. It's SOAP-based, and so inherently it's slow, and we didn't really have a whole lot of say into how that was used. We did get to add some functions into this web service. We added some endpoints that weren't there. We changed the behavior of a few endpoints, but largely it remained unchanged from start to finish. What they wanted was a highly scalable and fast but efficient website. They wanted something easy to manage. They didn't want something that was extremely quick but impossible to keep running. They didn't want something that was efficient but didn't offer enough functionality. So there was kind of a balance there of what we ended up creating with something that is very fast and it's also efficient, but it has, it's fully manageable via CMS. It still maintains a lot of the features that you would expect on a typical website, but it does things in probably a way that's a little bit unorthodox. So where they were at, again, this was pre-April 2014. This was Donatos.com. I don't know if this looks familiar to anybody. Design-wise, not great, obviously, but even worse, as soon as you leave this page, this is the only static page on their site. Everything else was in Flash. And that results in all of this lovely stuff. Just to get to the order page, so that you can place an order on this site, 200 normal HTTP requests. I mean, clearly that's a problem, just in and of itself. That actually resulted in roughly 5 megs of assets that were largely uncached. We looked for cache headers, we didn't see many. During that time, that web service that we were talking about, it hit it between 35 and 40 times, depending if you were already logged in. The 4.1 average, that's really only between the home page and the checkout page. So Really, the checkout page was about 16 seconds, and the home page was less than a second. Because again, this is all static. It didn't have to do much calculation here. Apache does decent at serving this out, but did really terribly at serving the Flash stuff out. It was non-responsive. They had a dedicated mobile site, which was horrible. That was their #1 customer complaint, was I cannot order pizza on my phone with your website. So I give up and I call the store. Again, it was Flash-based. So some of the challenges for us as we approach this redesign, planning, and development, their menus. It turns out the menu system for Donato's is very complex. Every store has a completely unique menu. Now, while you can order items that are largely the same in between Donato's, in their actual POS system, everything is unique. So they could maybe, if peppers aren't available in one region, they kind of take peppers off the menu in a group of stores, but it's all individual. So from a data perspective, we have to store every menu for every store completely independently, every ingredient, and the second line is what really throws a wrench in it. Every item is customizable, obviously. Pizza, everybody orders pizza differently. Everybody orders subs and salads and everything differently. We need to know what's possible to add. And not every pizza comes with every ingredient, but we need to know what possible ingredients there are, how many you can add, whether are you allowed to say you want it on half or you want it on the whole thing. There's so many rules that go along with creating a menu item that we have to store all of that data. The way that their POS handles it is 12,000 lines of XML per store. I knew I didn't like XML before this project. Sort of. Now I know. I do not like XML. It takes a long time to parse XML. And for a lot of reasons. There's a whole tree schema that you've got to figure out. There's all kinds of recursion that you got to do. There's objects that need created, and it's not something that we could do real time. That Flash interface that I was talking about earlier, it actually, every time you went to the site, was loading the 12,000 lines, parsing it, all inside of Flash. So there's your 16-second render, and that's without anything else. And so that has to go. Geolocation. So this was a really big topic for us. We wanted to make the seamless kind of ordering experience that was in our heads, and we knew one of the first challenges that was going to be geolocation. We need to know where users are before the first load of the page. We need to be able to, on the home page, present them with realistic options about what they can order. Again, if every store has a unique menu, in order to know what to display to them, I've got to know what store they should be seeing. So we developed a fairly intricate geolocation system that happens if you go to donatos.com today. It all happens in the background before your first load. Once we know who you are, we set a small cookie, and then we don't check that again until that cookie expires. Again, IP geolocation can be slow. There's a lot of different ways to do it. There's services out there to do it that you can call, but then you're relying on a web request. Before a first byte time, that's not acceptable. There's databases that you can use, but they're huge, and we've got to figure out a way to efficiently query that data and figure out what your location is. So we'll talk about how we did that in a minute. This was one of the wrenches. Halfway into planning, we didn't know this. Halfway into planning, CBS called and said we're going to re-air their Undercover Boss episode that featured Jane Grody, who is basically the CEO of Donato's today and part owner. When CBS airs something, a lot of people watch it. Believe it or not, people watch regular TV, I guess. I don't, but some people do. And it crashed their site the first time, which is understandable, right? If you're serving out 12,000 lines of XML that's generated real time by a Tomcat service, you get more than 4 people doing that, that'll bring down a server. They were seeing 4,000 concurrent connections from 9 to 10 p.m. and on till about midnight that day. So that's not going to work. The CBS, when they called, they said they're going to re-air it maybe at 8 o'clock, which is the prime time for television shows. We might get more viewers this time than we did last time. Make sure your site doesn't crash like it did last time. And I have an interesting story that we'll share about this happened. This happened in May, by the way. We launched in April. About 3 weeks after launch, the episode aired. So great time to figure out and iron out bugs for 3 weeks while we're getting ready for that. They wanted an on-site intranet and CMS. This was something that's not incredibly important, but it's important a little bit because it kind of illustrates that we need to be able to go from one network to another. We need to be able to push data. It needs to be real time. It needs to be, a typical kind of CMS experience. It needs to be very WordPress-like with some of their terms that they were using, which we didn't like, but it needed to do that. It also needed to be integrated into their local Active Directory. It's not incredibly difficult to do, but something to keep in mind. And again, it needs to push immediately out to the .com. So, our solution, and real quick, before I get into the tech specs of the solution, is anybody else here, were you at the web group that we did about the kind of marketing experience behind Donatos? I know Adam was. Is that it? So that Phil Franks, who's a creative director at Dynamit, and myself presented it with the Columbus Web Group, which is a good meetup here in town, about 6 months ago or so. And there's a video online if you ever want to watch it. There's a lot of decisions we made into why we put elements in certain places or made certain design decisions or even tech decisions that I'm not going to get into too much here. I'm going to try to focus more on the tech. But if you haven't seen that and you're interested at all into the marketing characteristics of the new Donatos.com, definitely check that out. So here's the new site. This was a screenshot I just took the other day. So it didn't launch exactly with this. There wasn't a login when we first launched. There is now. There was not this returning customer. Click here to get your favorites, because again, there wasn't a login. So there's some features that we've added since launch. Definitely a lot different, right? I mean, there's kind of a very experiential interface, very clean on the outside of that. Not a lot in the way of assets that need to be loaded, which is something that was a design decision. We didn't want to load a lot of images, assets, anything really to get the first load. What you can't see down here is quick picks. That's for those menu items that need to be loaded on first byte time, because I need to know again what store they're at. Which, when I go to it at work, is my Donatos for downtown Columbus. You go to it somewhere else, and based on your IP, you'll get a different location. I don't know if any of you here have experience with IP geolocation. It's not incredibly accurate sometimes, so we try to get your closest match. We realize that might not be your best match, so this could change during checkout depending on what your options are. If you say that you're delivering to an address, we re-geocode that address and see what the closest store to that is. Also on phones, we throw up the JavaScript nav and geo call and re-geocode based on the GPS, which is much more accurate than what our IP geolocation can be. Store hours, that's another thing. We need to know how late your store is open, so we've got to know that store ahead of time. This type your order here bar, that's something we'll talk a little bit about. That was an interesting feature to try to implement and keep the a good experience behind it. The design decision to have it there, I think, makes sense, but keeping it effective and have it really work is something that's a different story altogether. So our approach at a very high level is to develop, get a lightweight, responsive interface together, which again, on the surface, very simple. In reality, this was a decision and kind of a workflow that Phil, the designer, and myself had from day one. We wanted to keep it very lightweight. We didn't want excess elements. We wanted the CSS to be as small as possible. We didn't want to use any frameworks. We wanted to keep everything on a very light grid, so we didn't really need any frameworks. We wanted to minimize those POS web service calls. Obviously, like I said, if it's generating XML that large, you cannot call that very often. So we actually have a background service that does those calls behind the scenes and gives us the data ahead of time. So more like prefetching than real-time calls. We want to use memory a lot here. One of the really cool characteristics of Donatos.com is that for new and returning users, if you go to Donatos.com, it results in 0 database calls, and it results in 0 file I/O from the file system. That was something that was incredibly hard to achieve. Memory is really quick, clearly, but how to properly store things in memory is something that's entirely different. So some of the things that I did on the site we'll talk about in a minute, but it involved a lot of, memcache is what we end up launching with. We've since switched to a Redis platform, but essentially it does the same thing. We looked at MySQL bottlenecks a lot. Databases are great for a small user base. Databases are slow for a large one. That's something that most people realize and most people know. What we wanted to do is figure out when the MySQL calls were necessary. When do we really need a database, and when don't we? And let's figure out how we can eliminate those calls. That's what we ended up doing. The first MySQL call that you can make on this site, there's actually 3 places that you can initiate a database call. One is if you submit a contact request. If you submit a contact form, you've got to store it somewhere. 2 is for the newsletter. You sign up for their newsletter, same reason. And 3 is if you place an order. There are some things we need to do when you place an order that we have to store some things in the database before it goes over to that web service. So we do that. Otherwise, you're largely not talking to a database on the site, which is really interesting. We in the background try to prefetch all that data, get it in cache, so that it really reduces the usage of MySQL. And then from the bottleneck perspective, we handle that in a different way too. We do have at Dynamit sort of a custom micro framework that we use for PHP. We've inherited a lot of features over time from a variety of popular frameworks. We don't actually use any of those in production very often because generally the requests that we're getting from clients are very specific like this, where something needs to be tailored and created for them anyway. That's not to say that we don't. We certainly do deliver solutions outside of that, but largely this is what we use. So that's the approach that we wanted to stick to. And then we'll talk a little bit about how we did that. So again, we launched with using Memcache a lot. Just to store menus, just as an example, I wanted to throw up a stat that really illustrated what we did. To store the menus for every store, there's 160 locations of Donato's stores, by the way. To store all of the menu data that we needed, all of the configurations for items, all of the information we needed about default pricing, all the location data itself, and, how late are we open, 170,000 entries into Memcache. Well, it's not, if you know anything about the scale of Memcache, it's not really that big. Memcache does a lot more data transfers than that. And so we leveraged it in a really good way. It was only about 95 megs of memory. So I think currently today we have a 200 megabyte memory allowance for Redis, which is our current install. But again, we're using mostly just gets and sets within Redis, so it's essentially the Memcache functionality anyway. We use multiple object indexes, which is kind of an interesting scheme that we developed along the way. One of the things that you'll notice immediately, just kind of if you start thinking through not using a database, well, how do you locate something? I use queries right now to be able to find stuff and then display it out to the user. We came up with some pretty interesting indexing schemas to allow us to do that as well. So every object in the system is indexed in a variety of ways. Sometimes it's their ID, which is certainly necessary. I have object IDs, I need to be able to pull it out of the database. Sometimes it's the web accessible kind of URL. So for pages, if you have a unique page that you need to be able to pull the content for, we need to index it on whatever the URL was. That's all we really have. That's the only information we have about what they're wanting to request. And then sometimes, for the autocomplete bar that we're going to talk about, we're indexing things based on what they would search for. If I type in pepperoni pizza, I need to be able to index what those results should be on those terms. So again, 170,000 entries, really speedy. Most of our accesses are within this install that we have are less than 1 millisecond. So it's just a memory. If you think of it in hardware architecture, it's just a couple memory reads and get the data back and you're done. So really quick. However, in order to actually use this, we developed some cache models within our micro framework to abstract the fact that you are actually interacting with Memcache. That was the easiest way that we found to, as we're going through and programming the site, maintain some level of readability in the code versus actually having that raw performance. So we developed for every model on the site. So if you think of it in terms of ingredients and menu items, and stores, and menu groups, and all kinds of different models, they're all abstracted. But in the end, they all get back into memory. So how we really populate the cache is another interesting point. If we have a real-time CMS pushing out data, We have POSs that are making changes all the time. And then we have a MySQL server that we don't want to talk to too much. How do we actually get all of that data into memory? And so what we come up with was a schema of nightly updates. So every night, and if you ever go to Donato's at between 6 and 7 a.m., you'll notice it might be a little bit slower. And I mean in the fractions of milliseconds. This isn't taxing our hardware enough, but it runs every morning or night, depending on what time zone you're in, 6 to 7 a.m. We are updating all of the memcache, now Redis, installs with new data. However, we certainly understand that sometimes things happen during the day that cache needs updated, so we also have, because of our model abstractions, we have a very easy method within the CMS to trigger a cascading cache update based on a model. So if I tell a model to update, let's say it's a menu item, which can appear at multiple stores in different configurations, as soon as that update's triggered, memcache is then pushed, or data is pushed to memcache from all of those, everything that relates to that model all the way on down. So if it's a menu item, we recache the ingredients, the available ingredients, the pre-selected ingredients, what menu items are available with that name, how do we get to it from the autocomplete bar, and a variety of different ways that are cached in memcache. Yes?
What happens if you lose an outage?
It's a great question. It takes about 15 minutes to spin one up. So this has to be, technically,
Rewarm your cache.
essentially, yeah, we have to repop the cache. Now, having said that, these are all, there's also a trigger that says the first time you access that model, if it's not in cache, go ahead and cache it and then continue operation. But the stampeding effect of actually doing that in real time would probably eat up a whole server, so there's no point in having it online until that's populated. So yeah, it actually does take about 15 minutes. So there is, in theory, if all 4 servers, which is currently what we're running for the front end, if those all came down at once, we would have to have 15 minutes to spin those back up. So. And the reason why I said it's an hour is because we have 4 of them right now that are running 15 minutes each. If we add servers, it could take an hour and a half, 2 hours. We've actually been up to 6 servers before to plan for something that never actually happened. We thought they were re-airing again, and then they ended up not re-airing it. I guess that's the television business. But so we're back down to 4 now. Browser caching. We definitely used a lot of this. So every CSS file, every JS file, every image, JSON, XML, essentially everything but HTML are cached for very long periods. These are not all that strategic. It looks like there's a reason why these are a year and those are a month. These are more likely to be updated than those, and we chose numbers that were far enough off that we don't have to worry about the user re-requesting those. We avoided the use of uncached assets, so if there's something that we knew couldn't be cached, or even an asset, for example, something loaded via Ajax that the browser is going to do a 304 request anyway, we don't want that. We want to eliminate the use of anything that could come back to the server and do all 200 from cache. That's what we want every time. So this is actually pretty easy to implement. For us, it was just adding some rules in an htaccess file to make sure that these headers went out with all the files on their original request. The harder part is figuring out which part of these should be doing that, and which part we should move off to a CDN. We did quite a bit of research here. We figured out that for us, these assets were small enough that it wasn't really worth the cost of throwing them off to a CDN. If at some point we add more servers, if Donato's blows up to 1,500 locations, this method probably doesn't work. We probably need to just throw them off to a CDN, let them deal with the cache in the initial request, so that our servers never really have to know about it in the first place. All right, so geolocation. The method that we end up using, as you can see, is a database from MaxMind. It's about 1.8 million rows. Really, what that is just IP ranges. It says if you have this IP address, it's registered with a variety of different upstream companies. Originally, they all go to one company in the end that they have to be registered with, but it takes an IP range and it puts a lat long on it, so we get a latitude and longitude. That's really about it. The interesting thing is what we did to try to eke out some performance here. The first time that we did this, we were seeing queries in the order of half a second. But you can imagine, even if you throw index on 1.8 million and you don't use hash indexes, this is going to be a pretty long query to execute. So we started doing some research and we figured out all of the advantages of B-tree search queries. And there's very few rules that you really need to follow in order to have a B-tree query. One of the things that you'll notice with this query that we ended up with is that it uses all greater than and less than with equals attached, which we don't really need, but keeping the equals operators in there, for whatever reason, the implementation within MySQL keeps our B tree alive. It has to have the equals, so we kept them in there. The other thing is an order by, which if we're limiting one, doesn't really matter. You're only going to have one result for each of these. But the order by actually cuts our B tree in half. So for every query that we have, if you order by and go in, it doesn't matter as long as one of them is indexed, you're cutting your search time in half. So what we ended up with is about 25 milliseconds for that query. That is actually a little high. Most of our queries are, especially if they're on the end of each edge of the tree, you think about it in terms of where they're at in the database, it comes back a lot quicker. That's worst case. That's very middle of the tree. It's going to take us, at worst case, about 25 milliseconds to find it. That's on really good hardware. So in our development environments, we weren't seeing 25 milliseconds. But then once we got into actually production hardware, that's where we got 25 milliseconds. And we were lucky enough that Donatos had kind of a server guy that was a consultant that was able to tune MySQL for us and get, eke out some, just with some memory configuration stuff, a little bit better performance here. But without the query, we would have been seeing much larger query times in general. Yes?
In what format do you store the IP addresses?
They are decimals, so they're just normal, really, I think in terms of data, I think they're 255-bit decimals, but they're 12 length and then 9 precision decimals. Yeah.
And then, I guess that kind of answers my question too. You're not worried about the IPv6 IPs yet?
No, and that's an interesting point.
And then the other question too is this 1.8 million. That's after you filter out like countries.
This is U.S. only.
Right.
Yeah, the original size was much larger. The IP version 6 thing is an interesting problem. It's something we're going to have to address very soon. I don't know if any of you guys have been on the LTE network for AT&T downtown. There are certain cases that you actually are now allocated and routed from the initial hop off of AT&T with an IP version 6 IP. And so we're getting reports of users that are actually accessing the site with those IPs. That's not going to work with this, so we need to go back and probably get an IP6 version of this, which is, MaxMind already offers that data. The registry for those IPs is not nearly as accurate, which is one of the problems. The companies that have bought up all of that space are not nearly as good right now as registering it because they're not in as wide of use. Yeah, something we'll address soon. It's a good question. So we're able to do geolocation. All of this can happen before first byte, and we're not too bad. That's a 25 millisecond penalty on first load, which isn't terrible. I'd like to avoid that if we could, but really we can't. We have to be able to know where the user is, and this is the best way to do that. So the autocomplete bar. How many people knew that you could do this on Donatos.com? Anybody? Yeah, these guys, because they've heard me talk about it. That's one thing we need to improve, and we hopefully will at some point. How many people have actually ordered on Donatos.com? Okay, several. So you can actually use this thing to craft your items, and I think it's awesome. I wrote it, but I think the ability to be able to do this is really cool, and I think we just need to improve the awareness of this, and this is something we've been trying to do since launch. Honestly, is figuring out how to put this there so that people know about it, but not be so intrusive, because not everybody's going to want to use it. So in here, I just as an example, I typed pepperoni with banana peppers. It found my keywords, and it said, oh, you want a pepperoni something, whether it be a pizza, but we didn't really specify. So we actually came back with a pepperoni stromboli and a pepperoni pizza. With banana peppers means I want to add banana peppers to it. So anywhere where I could add banana peppers, it went ahead and did that. And then in terms of search highlighting, we just quickly go through and highlight the search terms that are in your search. So yeah, pretty cool. Not entirely obvious when you first go to the site that it's there, but it's very intelligent in terms of what you could do. You could easily say pepperoni with banana peppers and no jalapenos, and it would remove jalapenos from there. which is really cool functionality. But if you think about how we can implement that and not touch a database, not so easy. What we ended up doing is kind of taking the problem of natural language, which clearly is a very complex problem, and we always say this, we sort of reverse the problem. Instead of thinking about parsing what's there, we parse what we were able to find one at a time and locate items, locate configurations, locate ingredients that match our terms, look for modifiers, and then go. So essentially what we ended up doing is pre-caching all of the search terms that you could use. So in this case, it's pepperoni and it's banana peppers, so that we have context about what they are. So we have objects in memcache that actually tell us what pepperoni means. It's an ingredient. It's also the name of several different menu items. We know what banana peppers is. It's an ingredient, and it happens to be a part of the Works pizza. It happens to be an available menu item on almost every pizza. And all of that's available in memory, real time, with code. And all we have to do is figure out a good way to model it so that within the code you're not really jumping through hoops to try to get the memory back into your application. Creating the list of modifiers, turns out, though, wasn't that easy either. So what we did is we did some real-world tests. We just had people test this thing and figure out what kind of things they would type. If the question is, if you want a pizza that has extra pepperoni, what do you say? Do you say extra? Do you say double? Do you say 2x? There's a lot of different modifiers that you can use to get there. But in the end, it's pretty easy in code to figure that out once you've created your categories of modifiers. This was another problem. The way that menu items can be configured is enormously complex, as I was saying before. You can do whole, you can do left, you can do right, you can do 1x or 2x. You have all these different things that aren't initially selected. With this Sriracha Jack, which is a great pizza, by the way, if anybody is a fan of Sriracha pepper. These are the default ingredients, but then we have all of these that are available. You can select any of these at any time. The web service that we use to get these ingredients, again, is not all of that fast, and real-time pricing updates becomes a real issue. If I add double pepperoni, for example, that pizza actually costs more than $14.49. It's actually $14.99, I think. So we have to go into the web service real-time to get those prices. In order to avoid the user from noticing that, what we do is we pre-cache the prices for all the default configurations. So by default, the Sriracha Jack is $14.49. We don't actually have to go to the web service until you make a change. And so that was kind of our paradigm of things. We want 90% plus of user behavior to be pre-cached and ready to go, and then we'll deal with how to scale that extra 10% as it comes. I don't know if we actually hit 90% or not, but that was our goal. I think we actually probably went above it, to be honest, but who knows. So there's additional modifiers here that are interesting. Different sizes, different crusts. Sometimes when you have a different type of crust, there are additional options. So for example, if anybody here is a fan of the garlic cups, just order the thicker crust. It automatically comes with a garlic cup. These don't. So this on the surface might seem simple, but again, some of the technical challenges and speed challenges of how to implement it weren't so easy. And the pre-caching has helped us in numerous ways. I think this was probably the biggest way. For you to be able to get to a menu item and configure it in a pretty quick way without caching it would have been kind of a nightmare. And this kind of just illustrates all the things I just said. Again, MySQL, has anybody here ever had to deal with MySQL clustering or scaling, data sharding, anything like that? Not something we wanted to deal with at all. It's not easy and it's not cheap. It's hard to keep running. It's hard to keep synced. It's hard to keep things operating smoothly. Some people specialize in it, and that's great. We don't, so that's something that we wanted to avoid. And we're able to do pretty seamlessly. I'll show you some stats here in a minute. Our MySQL box is the least used box in the entire production network, which it makes me happy because I don't have to worry about the data bottlenecks that could otherwise happen. Because everybody here knows as soon as MySQL quits, you're done. You're not going to get that back. It's waiting on connections that it's not going to be able to fulfill, and then you've got to restart, and it's a nightmare. So non-checkout page loads are the things that we focused on. Checkout, we're okay if we have to scale for customers that are ordering pizza. If we get to a point where people are ordering enough pizza through the checkout tool that we have to add servers, that's a great thing. We'll have the budget at that time to add servers. Not a problem. We can support a lot of orders here and not have to worry too much yet about scale. We do a nightly sync. So again, we have that morning sync that goes and populates the Memcache server, which is now the Redis server. How does the data get to there? Well, first it goes from the 12,000 line XML file, it gets parsed down in PHP, it then goes into our MySQL database and waits for that cache update at 6 a.m. So this actually happens at 2 a.m. So if you're a late night pizza order and you want to eat at 2 a.m., that is where you could actually notice a decent size slowdown if you order a pizza, because you might run into some MySQL calls that would otherwise, you wouldn't happen during business hours. So we are able to get away with just a single MySQL instance here. Again, it's one of the least taxed servers on the network.
I was just in one.
Donato's is regional. They go all the way down to Tennessee. There's one in Georgia.
They're all Eastern time zone.
Mostly Eastern. There's a few Centrals. That is something we had to deal with, was the time zone changes in terms of offering delivery times and different things like that. But mostly Eastern side of the U.S. They do plan on at some point expanding out, but at this point, the 160 stores are mostly Central Ohio and a little bit beyond. So, North Carolina, they have a few there. It's a franchise company, so if somebody approaches them and they want to build, which is exactly what happened in North Carolina, they'll do that. And they'll work to expand the market for you, but really it's up to you as a business owner to figure that out. The way that we tried to make this programmatically easier for ourselves, besides the modeling of cache objects in Memcache and Redis, is by really aligning an array of REST APIs alongside of our code. So the only legitimate way that we could find to allow for that admin and intranet system, which is on a different network, which happens to be inside of Donato's offices, versus the production network, which is at Expedient here in Columbus, is to provide REST APIs to do all of the core site functionality. So we have, I think there's about 17 REST APIs that we've made available that do a lot of the data work that needs done, so that the front end can just focus on being the front end. And there's a lot to do today about that service-oriented architecture and creating microservices. This is kind of an attempt at that. They're not so lightweight. I definitely wouldn't classify them as microservices. Some of the services, as an example, is a cache update. In order to trigger an actual Memcache update, it's a web service that you call with a certain authentication method, with a certain endpoint and a certain ID, and it triggers the whole kind of cache effect. There are others for placing an order, finding a location, getting a menu, figuring out what menu items are available, figuring out the customizations for a menu item. All of that stuff is available via simple REST web services. And that's what we use for our code. In our PHP micro framework, we have a simple view that just makes a call into the web service, gets its data, and then it outputs it to the screen. The interesting part of this, though, is that in order to eliminate those excess calls, because you can imagine if we're making calls to 17 different web services, that's a lot of back and forth before page load. What we did is we created a kind of a socketless connection between the front end and the APIs, so that there's no overhead. It's all loading objects in code, but it emulates the exact same things what a REST call would be, and so that all that overhead goes away, but we still have the benefit of having the REST services. That isn't to say that you can always call them that way or should always call them that way. I mean, the admin and CMS tools, for example, they don't call them that way. They call them remotely over the internet, essentially, via a private VPN tunnel between the two networks. But yeah, so that's how those work. User sessions. Donato's, while not a huge company, as we said, 160 locations is medium size in terms of nationality, but they're not a national pizza chain. They're not Pizza Hut or Papa John's, which has an enormous amount more scaling issues than we do. They want to be at some point, and we'll hopefully get them there. So we use lightweight cookies for just about everything. And I say lightweight, I really mean lightweight. If you go through and look at the cookies, there's not a whole lot of data in them at all. It is encoded. We just do a quick base64 encode on it just to obfuscate it enough that the user isn't entirely aware of what's in there, but we try to keep them lightweight. We don't want all of that data passing back and forth. You can imagine all of the original asset requests we were trying to eliminate, those become infinitely harder when they're attached to a lot of cookie data that you don't really need. So we tried to avoid PHP sessions in general to help with scaling. I think in reality, we have enough horsepower here with 4 servers to generate the number of sessions that we need. It's really about data storage at this point. There are enough unique visitors going to Donatos, which is about almost 1 million a month, that it doesn't really make sense to use sessions unless they're entirely necessary. They turned out for us not to be necessary, so we just kept them disabled. And still today, we don't use PHP sessions. So all of the carts and customizations and things that are in your cart, they're actually stored in Memcache, and that's kind of an interesting, paradigm. So one of the things that we had to do to ensure that that works is that we had to make sure that data is synced across Memcache so that if you get switched to a different server, you still have your same cart, you still have your same item customizations, everything's still ready to go. So in terms of that API, that's one of those benefits of the API. We were able to abstract the fact that you were actually writing to several different Memcache servers, and yet you were still doing just the one call. So what we ended up with, something that looks like this. This is just a very simple diagram that I've created recently to express to the client the need for a couple different things. So you're looking at client deliverables now. Again, we have the admin and intranet inside of the Donatos network. We have a MySQL box there that just stores some local storage. We don't want to be writing to a web database from either of these directly. That's really the point there. We have a UAT environment that we do some testing on. We then have a service that pushes out data. So when things are ready to be published, they're reviewed, they're ready to go, they get pushed out into the database. Again, this wasn't here at launch. These Memcache servers were all here. This is something that we've added recently. This is what runs at 6 a.m. every day and just updates this guy. We have sort of not sort of, we actually have a master slave set up with all of our Redis servers so that we have Redis slaves on each of these guys. And then our Redis master. So we just write to master, read from slave, kind of a common paradigm when it comes to caching. The Tomcat service was sort of, at times it was amazing. We loved this service because of the abstraction it gave us. It let us talk to the POS in the store, did a lot of really cool things. But the fact that it eats up so much memory, it eats up so much CPU, we couldn't really utilize it the way that we wanted to in terms of performance. That was not ideal. So what we ended up having to do was map a web server to a Tomcat server. Even though our web requests were largely asset files, our web servers are doing a lot more work than Tomcat servers are. You would think we could just get away with 1 or 2 Tomcat servers, but in reality we needed 1 per. At some point I'm hoping that will change. If there's one thing that I think we can improve here with the performance, it's to eliminate some of these Tomcat servers. I'm going to get to some numbers and benchmarks, but just a funny aside, the Undercover Boss episode airing that happened once we had launched, so the one that was in May, we didn't crash our web servers, that was great. We crashed every single Tomcat server. There were more orders going through Tomcat than what they'd ever seen. We actually crashed some store POSs, which was really exciting for me. Web servers stayed up, which was what we were trying to do. We actually had too much throughput. I don't know if anybody here is familiar with Java at all, but we had a pipes system that was transmitting data back into the POS, and it chugged and chugged and chugged, and we had a backlog of data that go through pipes that lasted hours, and it ended up crashing some POS. Didn't do it all though, and they were still able to take orders, and everything was great. So in that sense, it worked out. But we definitely need to figure out that Tomcat setup. And again, that's a project that's ongoing with Donatos, and we're going to be playing a little bit of a role. So the hardware that we ended up with, we do have just normal F5s, big IPs for load balancing. Those are kind of the industry standard, I think, when you're talking about non-cloud providers. We do SSL terminations, so we don't have to do that in Apache. That helps us a lot. In terms of performance, the F5 does the SSL and key exchanges really quick, so we don't really see much overhead in the way of SSL exchanges at all. We do have those 4 front-end LAMP servers. MySQL is not installed on them, so our M in this case is for Memcache. Now it's Redis, so I guess it's LARP server. 4 back-end, doesn't sound right. 4 back-end Tomcat servers, and then the 1 MySQL server, which again, public MySQL over there. Very little utilization. We watch it some days, and it never gets above 3 or 4% CPU. It does a really good job of keeping up. Again, because we're not really talking to it that much. Every server is configured with 4 CPUs. They're Xeon 2650s, I think, is the models. So they're like 2.2 gigahertz. 4 gigs of memory. It's DDR3. Quick, speedy memory. That's one of our requests that we put in originally. Is we want really quick memory. So all of our memory requests are going through as fast as we could at the time. Now there's obviously faster memory available. But I think a year ago, and that's where we were.
Are you actually running your Redis on your web servers, your front-end web servers?
No.
Or you actually have that separate?
Well, I mean, in a way, yes, in a way, no. There is a Redis slave that does run on each web server. So every one of these has its own Redis slave. But all it does is it's a recache from master. I mean, if you know anything about Redis master slaves, within milliseconds we've got slaves that update after our writes.
When you configured your MySQL server, did you have to tweak anything in particular, or like obviously you're getting like 3% CPU utilization now. Like, is it even like a factor that you have to optimize that after optimizing?
All of our performance results are after optimizing. The only reason why, honestly, we optimized is because we took all the optimization we needed here. This guy is used a lot. If you look at this is the database that stores all that Java Web Service data. So every customer that orders online gets data put in here. Every order that's placed gets data put in here. If you go and you look at your recent orders, for example, all that data comes back this way. So all that data is stored here. They've spent years tuning that MySQL box. So the consultant that I was talking about that we were lucky enough to have, he is very good at tuning that MySQL box. We applied all of those same tunings and optimizations to our MySQL box, even though we didn't really need them. Again, we're not. So I mean, it's good though because the geolocation query, which we do need to hit, probably runs incrementally faster. It's hard to say what it would run different. Now, as I said, on our development environments in our office, it was a little bit slower. We weren't hitting the 25 millisecond threshold for allowance of geolocation requests. We were in the 30 to 40 millisecond range, whereas this one it trims it down quite a bit. So percentage-wise, it probably does quite a bit. But yeah, so what's kind of missing here, this is more of an architectural diagram for Donatos that we were going over some things. All of these things here actually live on one physical box. So the service that publishes data, the MySQL server, very important that these two guys live next to each other. These 15-minute cache updates become 3-hour cache updates when these are network requests. So these, very important. I mean, you can imagine writing 95 megs of structured object data within a 15-minute span probably isn't going to happen when you think about the processing time that you need in order for that to happen. So, so all these are in one box. So technically, there's a fifth server here that's unlisted, but it's the MySQL server that's listed here.
That cache warming script, is it like, is it also written in PHP or is it written in something else?
It is. Everything's written in PHP. Everything backend is written in PHP. If we wrote it today, we probably wouldn't, to be honest. But it was at the time, it was the thing that was available to us. We have the most developers in the office as PHP, and so it was easier to support. It didn't really matter how long that took either. It didn't. If it took an extra few minutes, as long as we're not bringing a server to its knees, it didn't really matter how long it took. So I think there are definitely more efficient solutions of it that we could run. Something closer to Metal would probably be a good solution, whereas PHP doesn't. We're using it out of convenience more than anything. So
you're using it though from the command line for that, right?
yes, we are. We have crons that run the actual PHP execution, and it's just a PHP command line call. Yeah. So benchmarks of where we really ended up here. This is a tried, true, tested number. We did a lot of load testing. We fired up so many JMeter scripts I couldn't tell you when we were in development to do a lot of this stuff. 70 milliseconds average. Homepage is actually a little higher. I wish the average load of the homepage was 70 milliseconds. It's a little bit higher than that, mostly because when we're doing JMeter tests, we're doing unique sessions, so we're getting geolocation requests that happen every new session. So we can't prove that that's lower, but we know in fact it really is. The 500K of actual weight. We go back here, and look, that's not a small image. Neither are these three. So we have to load all of that stuff. I wish that wasn't there. I fought to make sure that we didn't have a slider, and then of course we end up with a slider. I was at a talk from Brad Frost a few years ago, and he said that people implement sliders so that you don't fight in meetings. And I think that's really true. You know, that we're satisfying a lot of different people's requests for what they want on a homepage here. Marketing, IT, sales, like everything gets its own place here. And I'm pretty sure that that's...
What kind of fall off your secondary pages or secondary choices have?
What do you mean?
Well, in the slider.
Oh,
Are they
yes.
Are they click through or are they just visual? Is it just a like if you click on Sriracha Jack, does it take you to the Sriracha Jack thing?
It does not. There are some that have CTAs and there are some that don't. This one does not. Again, I'm sure somebody fought in a meeting over it. The point of this was to introduce concepts. You know, one of the big things that at launch this banner was for a long time is it showed you how to use this. It said, hey, you know, you can type your order up in the order bar. At some point, someday, I'm hoping that we're going to get a chance to reevaluate what happens here. We do have very intense analytics across the entire site, though, and we talked a little bit about that in the web group presentation that I was talking about. We do know how many people use this and how many people advance and how many people end up converting based on people that did advance and that. Most people don't interact with this, though, to answer your question in short. The majority of the homepage interactions that we get are up here or they're down here, which is where the quick picks are. I wish I had taken a screenshot of that too, but that's where the majority of our homepage conversions come from.
Has there been a concern about retina displays yet with this, or?
In what way?
Like that image would be twice as big to be a.
We scale everything. I mean, we have one sprite that we use for all of the images. Obviously, we have a 2x sprite and a normal sprite for all the retina stuff. This image at 2x with higher DPI, it certainly would pixelate more than it is now. But these are high enough resolution that we tried to accommodate kind of mid-range for that. And this is just a background size cover, so it scales as things go down. Again, it's fully responsive too, so we had to accommodate a variety of different viewport sizes with all of those images.
Shit, square IU.
Yes. Graceful degradation is a wonderful thing. It doesn't look this good in IE8, but it works. So that was kind of our philosophy. IE9, yes, we did a lot of testing.
You just measured background size cover.
Yes,
It's not
we threw in a polyfill. It's one of those things I don't like to do, but it literally is only on IE8, so I'm not worried about the request. I'm not worried about the size. 1 point something % of people is what we're dealing with on Donatos. So. This is the number I was really excited about. So we eliminated, if there was actually some pages that have 0 cached requests, which is amazing. This is what brings this number to a reasonable level when you do need to do that first initial geolocation before first byte. This number I wish I could get down, and hopefully we will at some point. But regardless, this is a number I took yesterday off of both of these. These have grown quite a bit from launch, actually. 39K CSS, 43 of JS. We recently created a new build platform that we're using, so some of this is overhead from what our new build platform is compiling down to. And some of the CSS is just new features that we've added. We've added quite a few features that we didn't have at launch. This was actually like 14 or 15K at launch of total CSS, which we were pretty excited about. That includes everything, and I guess I should have put a little disclaimer here. That doesn't include the one font file that we need to that we need to load. But again, it's just one request per, and it's fully cached the same as all of the other requests are. So technically, I guess this should be about 10 more K, because that's what our font files end up being, is about 10K per. So, in order to get here, I think most of us in this room understand what frameworks are really good at. We could not have gotten here with most front-end frameworks, certainly within the CSS, probably within the JS too. If you remember back, this is a whole JS nightmare when you think about what it really needs to do in terms of updating views and figuring out view states and figuring out, when I check this box, I need to display more options here. What do those look like? When I change this to a different type of crust, I need to add a garlic cup or a marinara cup. There's different just application things that need to happen. And in order to do that, we kept all of that logic, all of that view rendering, all of those client-side things at the end of the day down to 43K total. There was a lot of, I don't want to say infighting, there was a lot of decisions that had to be made during development to make sure that that number did stay down. There were a lot of features that we ended up having to figure out creative implementations of to prevent it. For example, just trying to implement this using almost any type of front-end view renderer is not going to happen in 43K. And I think React is the new hotness in terms of view rendering, and it's decently small, but we definitely would not have been able to write all of our existing JS and throw in React in 43K. Now, it's not to say it has to be 43. This may very well at some point become a React app because it's so much easier to maintain and implement, but initial launch, we did not go with any of those technologies, and we maintained a pretty small asset base. So, this is one of my favorite pictures to look at in the world. This shows one, I wish I could have more of this on the screen, but this is just a basic top of one of our web servers running during, this is kind of a peak Friday night. The really interesting thing about pizza is that almost everybody orders it from 5 to 9 p.m. on Friday. We're excluded, we didn't order it today, but for whatever reason, if you look at their Google Analytics, it looks like a perfect heartbeat. And then Friday happens, and it's like the guy got really excited. Just every Friday, it's truly, they do, I think I've heard a lot of different numbers, they do like 70% of their web business between a 3-hour span on a Friday night. If it rains, it's even worse. If it snows, it's way worse. And if it's a holiday, forget it. It's just the way people order pizza. It's always been that way. I don't think any of that's going to change. This is an example of a kind of a normal Friday night. We had about 2,000 concurrent people. To handle those 2,000 concurrents, you got to think, splitting up those requests across 4 different servers. We're at 19.8% CPU. You can't see it exactly. We have 4 gigs of memory, as I said, on those servers. We're using 1.5 gigs to service all of those Apache requests for about 500 concurrents per server. So, yeah.
What's the average time the user's on the site?
That's a great question. I don't know. If several minutes, but I'm not sure.
Is there a mobile app? And if there is, does it interact with the website or?
The mobile app, there are 2 mobile apps. There's an iOS app and there's an Android app, and it is an iframe web view, depending on what platform you're talking about, of the site. So it's an app, but it's not an app. That's something they're actually looking at redoing too. So, yeah. So the interesting thing here, you have 50% mobile. That's not a huge surprise, I guess, in today's world. 33% desktop, 18% tablet. I'm really glad that we spent so much time focusing on the responsive part of it, because we're only using 33% of the time the actual full site that we think about as the site. All of the features that are available on the full version, we don't take away. As we scale down, we keep every feature all the time. We do track all of the orders and things. We have extensive tracking that we put in to know who's mobile, who's not. who converts more on mobile, who converts more on desktop, what type of CTAs on the homepage generate more orders on mobile versus desktop. There's a lot of different things we've implemented. We've recently started doing some A/B testing, which is something that's really interesting. If you go to the homepage of Donato's and you're in the Columbus market, you will see some funky things happen from time to time. Things will be in different places, buttons will be there that weren't before. Do me a favor, don't refresh. Please do whatever you're going to do on your first page. And we'll learn a little bit about your behavior there. So we tuned Apache a lot. That's something that we did have to do after launch. We noticed that during these Friday night periods where things were getting a little busy, our Apache threads were taking up a little bit more memory than we wanted, which means PHP was taking up a little bit more memory than we wanted. So we optimized some of that down, tried to get our memory usage within PHP down to as small amount as we could. That actually meant at one point removing our ORM that we had built in entirely, so that we could just chew through database results a little bit easier, avoid some of that object overhead that happens during instantiation, things like that. Didn't want to have to do that, obviously. It's a lot easier when you write code that's it's all ORM based and things make a little bit more code sense, but that overhead meant we were either going to add a server or we're going to remove a few lines of code, so it turned out to just remove a few lines of code. Me being the performance enthusiast that I am, I actually liked that. Some of the other team members that are actually managing the code right now would probably disagree. So, yeah, that's about it. Does anybody else have any other questions about the specific way that we implemented anything? Oh, sorry, I couldn't see your.
Oh yeah, sorry. Well, I guess I have three too. First, are you using mod PHP or like FastCGI or PHP?
We're doing normal mod PHP. We've experimented with doing some basic off caching and things. It didn't help us that much. I think the actual, in terms of execution, you can see our CPU is pretty low. The biggest thing for us was just memory. Keeping memory use down. The precompile stuff and the actual execution wasn't really killing us that much. There are certain scripts that it would, though, for sure. Keeping the caching, for example, the caching script that chews through all of the database records, that would certainly benefit from that. But that happens once a day per store, so 160 times a day or so, all between the hours of 6 and 7 a.m. So that it hasn't turned out to help us that much. I think at some point we definitely will, though. We'll bring back. We have the server setups that we need to enable just some basic off caching. We've talked about converting this to non-PHP hack or something, just put on HHVM, something like that. But again, we're not. I don't think we're that concerned about the execution time. We're much more concerned about the memory time and the bottlenecks around the data exchanges, and that's what we tried to focus on. But definitely could help us as we horizontally scale for sure.
What version of PHP are you allowed to share?
Anything we want. We have full control over the servers, so we can absolutely install. We're 5.5 right now.
Yeah.
We could easily go 5.6 or above and beyond at some point.
I had a couple questions. One, did you guys write all the HTML and remember the HTML on the PHP side, or did you sense that there were JavaScript?
It depends. Almost always it's all front end. It's all decoupled front end.
Okay.
There are a few cases though where certainly there are some things that are rendered. I'm not sure if our internet's going to be good enough here to do this. It just works, right? Mm-hmm. Okay. Just yeah. So 78. I wasn't lying. So there are certain things that are rendered client side. There are certain things that are rendered in the back end. One thing that's rendered in the back end is this. That call being as fast as it was, I'm exceptionally proud of. And I'll tell you why. This is a list of locations that are closest to where we're standing right now. It's the closest, I think, 20, 25 locations. In order to be able to load that, we need to know all of this lovely data. So we need to know all of their store hours, all of their basic information. Again, no database calls resulted from this. There was one database call that happened on our initial load, and that was to get our lat long. And from there, all of our calls are just memcache, well now res, object instantiations and comparisons that happen all the way down through. So this is an example of a page that is rendered PHP. We actually loop through and create the markup in PHP. We could, at some point, convert this to just being fully decoupled, and I don't think we would see any performance gains or losses based on that. It's just, we didn't really have, again, with 43K of JS, we didn't really have a whole lot in the way of frameworks or structure to actually allow really complex view rendering. So it turned out to be easier to do that on the server side. I'd love to see it go more front end, decouple it a little bit more, but I think this page would just have to change in terms of the structure a little bit to make that happen. So.
Also, just out of curiosity, I mean, looking at, what, a year-ish later,
Yeah.
What do you feel like were the biggest learns, the biggest gains, or what do you maybe feel like, oh, this is the biggest regret, I wish we did this differently? I mean, I know the Tomcat server obviously is out of your control.
Yeah.
But within your guys' control, what do you feel?
There are definitely things that we learned. We initially launched without login at all. So as you were typing in your email address or phone number, a lot of things happened during checkout, essentially. We were looking up data about you based on your phone number or email. Have you ordered before? Is there a recent location that I can pre-populate into the boxes? People hated that. I thought they would love it. I thought it would offer a really seamless and quick ordering experience. You can go in and within just 30 seconds, 40 seconds, you'd have a pizza ordered. Turns out that the speed of the thing being 30 seconds or a minute didn't really matter. They wanted that login so that they could feel secure in the data that's being stored, even though it really was secure, because until a certain number of conditions matched, we didn't actually get any of that data. The address had to match, the phone number had to match, the email had to match. There's things that had to happen that most likely nobody else is going to really have anyway. So that was one big learning. From a tech perspective, we learned a lot about caching. I didn't even go into all of it today. Figuring out how to put things in memory and get to them and access them, that was, we learned a lot about indexing. We learned a lot about, how many objects can I realistically fetch in one connection in memcache, and how does that scale horizontally. Those numbers are somewhere in between 60 to 70 memcache requests that we can realistically do before we start to notice some sort of scaling effect as we ramp up. Again, we did JMeter tests every day as we were developing this thing, and as soon as we noticed that those connections went up, then the CPU usage of memcache was kind of unreasonably high. We learned a lot about how to handle geolocation properly. Like I said, we knew how to do it before. We never really focused on the performance of it before. So that was something that we learned a lot about.
So are you thinking about going forward using memcache more for any kind of these small and medium businesses that may not have a massive data store?
Yeah, this framework of architecture and the way that we coded this, we're reusing quite a bit now, even though we don't need it necessarily. Tire discounters is one that we recently did, where it does use the same architecture, but there's only 2 front-end servers rather than 4. Their traffic isn't quite as high. Technically, we could probably get away with just using 1, but it's nice to have the 2 so that we can take 1 down, do code updates and do releases, and then switch the load balancer off and do code updates and releases that way. So, what else did we learn? I think the majority of what we learned outside of what I've already talked about was more of design-related, UX-related things, which we talked about in the web group presentation a lot. Phil was great at listening and talking with me, and hopefully I was the same for him as a sounding board to talk through a lot of those things as we were in heavy development. So.
Just out of curiosity, I mean, you may have discussed this in the web group, and I apologize.
No, it's fine.
But why did they approach you in the first place? There was like a bidding war between different companies, or how did you guys get the? There was an RFP sent out. We responded to the RFP. They liked what we had to say. They came in and they interviewed us along with several other agencies, and we were lucky enough to get chosen. So.
And that's the way most projects are introduced. You know, I think we handled that in a very unique way. I think you know, one of the things that we did was we came in and told them about the things they were doing wrong, and we weren't afraid to tell them about those instead of, you know, patting them on the back too much during the RFP process, and they liked that. So you know, that turned out well.
I wanted to ask a little bit about the you know, crypt tiger order.
Yes,
Order.
let's play with that one.
Like basically, is the indexing like, is there like a global index of terms, and then each of those objects has its own properties, or is there multiple like
Almost exactly
index
that.
queries? Okay.
Almost exactly that. So we have a global index of every category of thing. So that is menu items, which, you know, pizza, sub, whatever categories I should say. Menu items themselves, so all of the pizzas, all the different subs, and all of their names. That's all that's in Memcache is a list of all their names.
Yeah.
So basic string comparisons can tell us if any of those appear in the string. If they don't, we start with a pizza. If they do, we start with that item. From then, we search the string for the other categories. All known ingredients. Peppers, banana peppers, onions, sausage, pepperoni, all those things. From there, every time we find one of those, we look for modifiers. We go back one word, and we look, did it say without, or extra, or no, etc. In code, we then know what to do. We either add extra, we either remove, based on what it is. The one sort of caveat to this is that most people don't know how to spell words. I'm kidding. There are common misspellings, though, for things like pepperoni. So you can type things like pep, and it still understands that as pepperoni. So there's one additional index here that I didn't talk about, which is a list of the things that you actually typed versus the list of things that you probably meant to type.
So it's like a map.
Yes. So pep and pepperoni and all the different ways you can misspell pepperoni, we hope we caught them all, will actually translate and get converted into the word pepperoni. Same for, and this system, this paradigm helped us because certain pizza companies refer to things differently. A Supreme pizza doesn't mean anything to Donato's. They don't have one. They have one called the Works. So what we did is we translated the term Supreme to the Works. So we used the same concept that we were using for misspellings, we actually used to help us. So this is how we get the special things that are built in. Larry's the guy that works at Donato's, he loves cinnamon bread. There's a variety of different things we did like this that, you know, these are just fun, but there's other things that we did that helped us in that way too.
Do you log those? Do you log those query strings?
Every one of them.
Okay.
Yeah.
And so like you can basically, in other words, you can analyze those.
Yes.
Later to, oh, they probably meant this.
Yes. We generated. Let me get this number right. Our peak month for interactions with this was somewhere around the order of 260 million entries. Yeah, in 1 month. So we haven't actually went back and looked at all of them, but we did look at the common ones, and it was actually people misspelling pepperoni or people searching for web content. That's one of the things that people do here a lot that we need to probably address. Yeah, they search for things like coupons or I mean all the things that people usually search a site for. Locations. For example.
There's a search box.
So again, this is that sort of front end app architecture that we have to be able to do this. This is what I was saying. I haven't actually talked to the web service yet. I haven't done any MySQL calls yet until right now. So that, I don't know if you saw the little loading indicator, but that's how long it took for me to contact the web service, contact the database, and get back with new data. In that actual item, it didn't do anything because it was just a special instruction. But if I actually do something like, you know, adding things, it actually needs to do a little bit of work and get me a new price. So that's how we eliminated, again, some of those bottlenecks and reduced just the number of overall calls. So all of this, other than the 2246, was pulled from that.
You get any negative feedback from people who were expecting it to update in real time, and they're like, "Hey, I have all these things, and now it's more expensive."
It was, I haven't heard feedback, but it's definitely something that we thought about during the design process. We wanted to make that save button pretty clear where it was. There's actually 2 of them, so if you happen to be down here, you can get to one. I mean, you can't really see the price here anyway, so there's another thing. You know, you can only have a certain number of menu ingredients within an item. All that data needs stored, and so that's what that 95 megabytes of stuff actually is, just all that data that's behind essentially configuring these items. Everything else is pretty simple. Item configurations, again, hand tossed for the marinara cups. Free marinara and garlic sauce, if you ever want it. Yeah.
Is the 9 items a business rule or or a technology?
It's a funny story. It's a technology rule because their POS can support a certain number of characters in a line item. Yeah.
The bread can't handle it anymore. It's gonna collapse in there somewhere.
It's a
Delivery man.
so what that
They'll have 9 buttons on the register.
no, it actually means that the data they use to display things on their POS has a certain character length, and the number of ingredients here is also very strategic. They actually, if they want to add an ingredient, so when they did the sriracha peppers, that pizza, they had to choose what other ingredient they wanted to get rid of. They couldn't add anymore. Now, luckily, it was some sort of mushroom, I think, that they got rid of. It was like a specialty mushroom.
Nothing else.
But it was the same principle. I mean, their POS had limitations of how many characters it could support, and that's fine.
Until someone says one symbol means 2 different toppings at the same time.
Yeah, I mean, they have a lot of different business rules for encodings. They truly have bits that mean each topping, and so they have a certain number of bits that they dedicate to each thing. And these are all codes in their system. You know, this is 001, this is 002. So.
You want to talk a little bit about your testing process for this? Some of the more complex items.
What do you mean?
How did you ensure that your fake natural language search and some of the other more complex things were properly tested?
Well, I mean, we just used them a lot. A lot of this stuff can be automated. We do have some unit tests here. All of those web services that I talked about, we have roughly 17. We do run a quick unit test on all of those to make sure they're still returning good data. They do all the good things that we want them to be able to do. We have, I probably shouldn't type in too many things because you guys can see what I'm doing. There is an interface into the cache system that I can use to get into the cache system. Those are all automated in terms of test, but in order to do the autocomplete bar, we did do a lot of user group testing. We actually set people down with this. We watched them, we videoed them, we watched as they're typing and see what kind of things they would type, how they would type it, if they actually went to it at all. There were some people that we just didn't tell them about the bar. We would see if they would find it and figure out how to discover it and use it. There are a lot of different search terms that we used as QA tests here to make sure that it was working. One of the ones that we always tried to use was pepperoni, again with 2 P's, not 1. So something like with no onions. Well, none of those had onions. Let's say the works. So you can see that there's no onions. Now there's onions. We did all those little things to interact with it to try to figure out, how it's working. Is it operating correctly? Unfortunately, the majority of customers don't really know yet about this, and I think in a way that's good and in a way that's bad. We've had enough time now that we know that it works. So we've understood the customer, we've understood how to get them to it, and now we need to just better market the usage of it and things like that.
How long did it take you to put all of this together?
A long time. I'm sure a lot of us here have estimated web projects and created estimations and figured out how long things would take. I tripled my estimates here, almost across the board. And the company, I'm lucky enough to work with a great company. They were thrilled that I tripled my estimates because it meant the product that we ended up delivering was great. A lot of that was in my own time. I mean, this is one of those things where I went home and I coded every day, every night, because I was kind of in love with this project throughout the time. But it took a while. I think from start to finish. So we kicked off the project in October of 2013. We delivered it in April of 2014.
The
So,
actual developers worked on it.
two back end, including myself, and 2 front end, including myself. So 3 total.
3 actual people.
3 actual
Okay.
people. I put in some overtime
We
here.
put in quite a lot of overtime.
Yeah. 3 actual bodies, about 17 on paper people.
What kind of project management and source code management do you use for this kind of project?
So project management, mostly Jira, and then code, all Stash. I don't know if you guys are familiar with the Atlassian suite, but it's a Git front end interface, much like a GitHub, but an Atlassian integrated with Jira type. So all Git. We do have a fairly complex branching model that we're using to actually store the code. We're approaching this project, among many others, more iterative, not truly agile, but then again, nobody really is. But we do have a lot of feature branches that go out. We do have, in something we put in service very recently that we're really excited about, is in our development environment, we're fully containerized within Docker, so we're doing release branch pushes from new containers and getting unique URLs and all that. So we're able to test this stuff pretty quickly.
Has Donna's been fully thrilled by what you gave then?
Yes, yes. Again, the web group presentation that I've referenced a few times, they were there. 2 of the head of IT and the head of marketing was there to kind of give their opinion, make sure we didn't say anything crazy, which is probably the real reason why they're there. They've been thrilled. And Dynamit is a great company. They give their people a lot of freedom to do their jobs, and they're not really, they stay out of the way, and Larry, who loves cinnamon bread, as I said before, he's the VP of IT. He was enormously supportive in getting us what we needed, listening to our crazy ideas, because some of this stuff was very unorthodox. We didn't approach this project from a way that most people would approach the project, and so we're telling them, we're not going to use any frameworks you've ever heard of, we're not going to code it in any way that you've ever seen, promise us it'll work, and that was, it took a lot of faith in order for that to work out. And yeah, they're thrilled now. We still work with them today, we still put in a lot of hours to make this better, and as I said, we've released a lot of updates along the way. So.
Great part of eating that pizza.
Yes.
So you and some of the other members of the team have talked about some of the numbers, some of the stats.
Yeah.
I don't want you to disclose anything that you are not supposed to, but there definitely was an increase in sales.
Yes.
So you're seeing some real numbers because of this project.
Yes. 150% increase in traffic overall on the website, which is great. Almost a 200% increase in online orders, which is very good. And then somewhere around a 70, this is the number I'm not sure of, somewhere around a 70% increase in check size for incremental periods, especially during our A/B tests. So yes, they've had very good results with the site, very good results with the ordering. Their goal and the thing that we really want is just to increase the amount of their business that's done online. So we've definitely done that.
Did you see, or have they reported to you a drop in the number of phone calls?
Yes and no. Initially at launch, they had an increase in phone calls because there were customers that were very familiar with that old interface that I showed you. So they were getting an influx of calls of people that didn't want to use the website. Over time, that's declined. I don't actually know anymore what the correlation is, but we've not heard complaints for sure. And I know that as the web usage goes up, it becomes a bigger part of their business overall. So the phone orders are definitely going down. Yeah. Yeah. So we do try to make it easy to find phone numbers on the site, but I hope that that's not the way that people end up going. I think some people do just like to order on the phone. It's something that's kind of baked into what they do, but we tried to reverse a little bit of that. So, and again, some of those really interesting design decisions we've talked about a little bit in the web group. So, 3 people. You were first.
All right. Mine'll be quick. Everything was based on the application. Are there still some pages where you guys had to put some thought into just the SEO, the web type, what Google should be seeing?
Yeah, I mean every page. I think we always do that to some degree. I don't think there's anything here that we didn't consider that in. Organic searches is not a huge part of their business, but at the same time, we still wanted to make sure that it was very SEO friendly. We develop all of our front end interfaces that way. With it's always, if not the number one concern, it's the number two concern behind user experience. So.
I just wonder, as I've been dealing with that new search box on Google, and how you combine that with your box, which is not for ordering.
Yeah, I mean, luckily not a whole lot of this is client side. Some of it is, but it's not things that would be indexed anyway. Like we didn't have to do escape fragments or anything like that to get good SEO behind it. So it turned out pretty good, I think, in that way. I mean, we're ranked really high in all of the major categories that we were high in before, and we're ranked even higher in a lot of ways now in some of the common terms. But again, organic search is not a huge part of the business. Most people know what Donato's is. It's not something that people are really locating via search too often, but we still want to drive as many as we can. So.
So two things. I just posted a link to Brad's original presentation if you guys are interested.
Great, thank
to
you.
the PHP discussion board. And then you mentioned the A/B testing. You guys are sort of doing in the Columbus market.
Yep.
What are you using for that? Is that Optimizely or?
We're not using Optimizely. We wanted to use Optimizely. The market that we were going to present to needed to be more dynamic in what we could do with the data that was in Optimizely. So either we set variables that we're reading in Optimizely, which turned out to be more code than it was worth, or we just implemented a quick if-then. So it's just a quick PHP. We're just using Google Analytics. We're using that as a goal conversion. So it's pretty easy to go through and see what the results are.
Is there any two-way communication? Like after you made your order, does the site reflect the status of the order if you refresh or look at it?
Not after the receipt, the thank you page. We are waiting for a POS response back. If you ever place an order and you notice it's taken 3, 4, 5 seconds, it's because we're actually waiting for a response from the real POS. And it gives us a promise time when your order is going to be ready. After that, we don't talk to it anymore about your order. So, but that's a good call. Some of the projects that we want to do with Donato's are things kind of down that line, tracking and things like that.
Where does the transaction happen? Does it happen on their POS at that store, or does it happen on a web store separately that then has to be accounted back in?
It's the real POS. So the order numbers that we get are incremental at the POS level.
And the POS is handling the communications to the merchant processing and so forth. Is that done?
There is no real-time e-com here, which is interesting. Your credit card number is encrypted and sent to the POS, which is then processed by the POS itself. It's done as soon as you walk into the store, so it's not actually a real-time.
For delivery, it's...
For delivery, they run it before the delivery driver leaves. If they have an issue, they'll give you a phone call.
And they batch it in the store?
Yeah, it's all batched in the store.
You mentioned promise time. I've always been curious about how that would work. I know some places it's not good.
Yeah.
Yeah. So how is that?
It's an interesting thing. Their promise time is actually a really interesting kind of algorithm that they've created. It's all in the POS, so it's no code that we wrote, but we have all the Java code to look at and to work with. So the more orders in their system, the longer the promise time, and they use sort of a log curve of how that accelerates over time. So if they have the number of employees calculates into that a little bit, the size of the store calculates into it a little bit, but essentially, if you think of just a simple, anti-exponential curve on a graph, the more orders they have, the longer wait interval that they use. So if there's 2 orders, there's a very tiny wait interval. If there's 70 orders, the interval grows pretty big. And so the actual distance between promise time between any of those orders is larger as it goes out. They cap it off at an hour and a half promise time. If it's over that, they just stop it at an hour and a half, and they just hope that the store can kind of fulfill those orders. Which, I don't know if anybody saw the Twitter dilemma or drama with Donato's a few months ago. They actually had that problem somebody tweeted out a coupon that they were not supposed to, that made orders entirely free. The website didn't crash,
Nice.
but that was again something where we sent an enormous amount of orders into their POS, and their promise times accelerated and skyrocketed.
So did they ask you to crash the website if coupon code equals?
Yes, actually, so within hours from the time that we found out that was happening, we went in and released code that said if you're using this coupon code, just invalidate the code immediately, rather than try to validate with the POS, which it was valid code in the POS, so we just didn't let it get there.
What is that code again?
It doesn't work. It doesn't work.
I've never seen a performance impact from sessions in PHP, so I don't use Memcache as my provider. So where does that start hitting in terms of volume?
I think if you're using Memcache as your provider, it's not really a volume thing until you run out of memory. You know, the more memory you can give Memcache again, it's a hash index, so it doesn't care about the size. You know, if you can give it 80 gigs of RAM, it can use all of them as efficiently as it could too. It's just we didn't have the available memory that we needed. We knew 4 gigs was our max in terms of memory that we were allowed to have. We knew that Apache was going to need a lot of memory.
That's based on what you're putting into your actual physical machines?
Yes, yes. They are physical servers that we have allocated. The memory usage was really the only reason. You know, I think again with Memcache, the scaling is not the problem. It's just how many sessions you need, how much space is that going to take up. Over time, the requirement for us was that we keep carts for a while. So if we have all that session data built up and stored over time, how many can we realistically support? We get a lot of unique visitors here, so that was just a question. It was easy enough to set a quick cookie than it was to try to worry about the session costs. But yeah, I don't think the performance impact of that would have been too big if we were able to use Memcache as a provider. And I think it's probably the way to go. If we ever do turn on sessions, that's absolutely what we would do.
Yeah, I think the confusion is some of us, we don't have to worry about having all the customer's data at every page load.
Right.
So our session is literally just an ID.
Yeah.
So in that case, it's fine.
Yeah, and you know, in this case, the session size wouldn't be that big because if we're just storing IDs of objects that are in memory that you have configured. You know, if it's an ID of a topping, if it's the configuration that you want, that's just a simple encoding that we use to specify whether it's 2x or just 1 or on the left or on the right. So it's, you know, it's not that big, but again, it's just a problem that as all of the other challenges that we had at the site added up, we didn't really want to worry about that one specifically. When that cookie is only, you know, you can see it. You can see it here. It's that cookie there, so it's not that big anyway. It doesn't extend much beyond what you can actually see. I'm dealing with a pretty small screen, so yeah, 515 bytes or bits, so not too big.
You want to talk a little bit about the hardware? I think at least initially you guys were looking at Linode for this one.
We weren't for this one. We were for the next one.
That's what. Okay, I have it backwards.
Yeah.
So for somebody else that might be dealing with a project that needs to potentially scale, you've laid out the architecture diagram, but you know, what would be, through your research, something that would be viable to use as a platform for that?
Definitely this. In terms of cloud providers that offer all of the things that we needed that you saw in that graph, definitely Linode. I don't work for Linode or market them in any way, but for tire discounters, we have a simple load balancer here that gives us access to, you know, all the servers that we need. Again, we have the 2 front-end webs for them, same kind of architecture that we use here. Definitely Linode. So if anybody's curious, that we host tire discounters for $120 a month. And that gives us, we tested it, we can go over 4,000 concurrents on that setup. In terms of, if you look at dollar per visitor, I don't think you can really beat what they offer. They're very reliable too, so we've never had any problems. And we use the New Jersey data center too, so regionally it kind of makes sense for tire discounters.
over what made you decide to put them over like some like DigitalOcean provides?
DigitalOcean would be great too. I like the load balancing options that you get with this. I actually deployed a node balancer, what they call, but it's a simple F5 model load balancer. It's a software load balancer, so it's not physical hardware, but
I believe the response time was a little bit lower too.
yeah, I did some testing with performance. The response times with Linode was substantially faster than DigitalOcean at times, for whatever reason. I think they might just be closer to wherever the hub is out in New Jersey. It's hard to say why, but I mean, DigitalOcean is an SSD cloud provider, just the same as Linode is. So I'd imagine if you didn't need to scale beyond one web box, DigitalOcean would be great. They don't have the load balancing options unless you actually create your own software load balancer with the deployed node, but that becomes a little bit more difficult to manage.
All right, if you don't have any other pressing questions, I think we'll wrap up. It's almost 8 o'clock, so let's let Brad know how well he did.